Okay, here's another way to solve systems by substitution uh, if the equations are given to you a little bit differently. So now just one of the equations is solved for y and the other one's not. It's in standard form. So you could solve the other one for y, or since this one's equal to y, we can take the 2x minus 2 and plug it into the other y. So the only thing that gets replaced is the y. Notice there's a negative in front of the y, so that will not get replaced. It will still be a negative. So here's what it would look like. That negative 6x would still be in front. Then the negative and then the y equals negative 22. Okay, so notice the empty parentheses there. That's where I'm going to put the stuff that is equal to y. So I'm going to put the 2x minus 2 in there. And now I can solve for x. So you can't forget about this negative. Think of that as having a negative 1 in front of the parentheses. And so you have to distribute the negative into the parentheses. So it's going to be negative 2x and then a positive 2. And then I'm going to drop everything else down. And now I can combine my x's and then solve for x. So since these x's are on the same side of the equation, they can get added together as they are, or subtracted, whichever way you want to look at it. So we have negative 6 minus 2. So they're both negative, so it's going to add and stay negative. So we have negative 8x, excuse me, and then positive 2 equals negative 22. Just drop down those. Now it's getting pretty easy. We just keep solving for x, so we're going to subtract 2 from both sides. And the negative 8x is going to drop down. Those 2's canceled out. Equals negative 22 minus 2, negative 24. And then I divide by negative 8 to get my x equals positive 3. Double negative makes positive. Once you got the x, then you take it and plug it back in for x into one of the two equations. Now in this case, the equation that's solved for y is going to be the easy one. So that's where I would go. I've got y equals 2x minus 2. So I'm going to take the 3 and plug it in for x. Okay, so I just took that 3 and plopped it in there for x, and I just evaluate for y. So 2 times 3 is 6. 6 minus 2 gets me the y value, 4. So again, write your answer as x comma y. And it's just good practice. Okay, so that's the idea. You substitute in and then solve. So I'll do one more here. So this negative 8x plus 1 is going to go in place of the y in the first equation. So I have 7x minus 6 times y equals negative 6. So in that blank parenthesis, that's where I'm going to put the negative 8x plus 1. And then you go about solving just as if it's a normal equation. So that negative 6 has to get distributed. Negative 6 times negative 8, so positive 48x. Negative 6 times positive 1, so negative 6. Drop the minus 6 from the beginning, and then drop the 7x from the front there. So now we go about, keep solving it. So combine your x's, and 7 plus 48 is going to make 55. Keep the x, and then drop this minus 6 equals negative 6. And then I'm going to solve for x. I'm going to add the 6. So negative 6 plus 6 leaves me with 0. So 55x equals 0. That's okay. Just divide by 55, x is 0. Okay, so x is 0. That makes finding y easy, because you take that y, the x, and plug it in to solve for y. So I have y equals negative 8x plus 1. Negative 8 times 0, just 0. 0 plus 1, y is 1. So my order of pairs, 0, comma 1. So there you go. You plug in for y into one of the equations and then solve for the other one. On the back, you see two systems of inequalities. So remember to get them equal to y. Graph them. Remember, if there's a line underneath the sign, like this one has, you'll have a solid line. If there's not a line underneath, you'll have a dashed line like this one. If they're less than, you'll shade below, greater than, you'll shade above. And remember, if you divide by a negative, so both of these you'll divide by a negative, the sign is going to switch. Okay, so if you have any questions, make sure you let me know.